Hello, Chemistry 11. This is Mr. Chan. And last day I gave you these four questions for you to answer in preparation for this unit. So basically you had to do a definition, you had to do a description, and you had to explain why an ionic solid does not dissolve in a polar solvent. Now, before I go to the description and the explanation of why for question number 4, one thing I want you to be aware of is when you're doing the definitions, please make sure you know the difference between solute and solvent. Okay, and the other thing that you should be aware of is the definition of solvation versus dissociation. Now, it's not to say the other definitions are not important, but what you want to do is you want to be particular in understanding the difference between solute and solvent, and solvation and dissociation. Things like homogeneous mixtures, heterogeneous mixtures, solubility, the other definitions, yes, you should know them in this unit because we will be using those terms, but please make sure you are aware of the difference between solute, solvent, or solvation and dissociation. Now, I want to just focus a little bit on question number 3 and question number 4. Describe the process which occurs when an ionic solid dissolves in a polar solvent, and why does an ionic solid not dissolve? Well, hopefully, one thing you should have understood is that why does an ionic solid dissolve is the key word is there's an attraction between the solvent and the ions in the solid. Therefore, what happens is that the attraction as well as just the collisions break apart the ionic solid. And why does an ionic solid not dissolve in a nonpolar solvent? Is because, excuse me, no such attraction exists. Now, if I were to share a different screen, just to show you, okay, what do I mean by the attraction? So let's say we had salt, NaCl. Now, NaCl is an ionic solid, and what happens, it has ions in, so ions, your positive ions and the negative ions, and notice the spheres are the water molecules. And what happens is these water molecules surround the ions, and the attraction is so great between the ions and the water molecule that the ions get pulled apart. Now, why is there this attraction? It relates back to the last unit, is water is a polar molecule. There is a partial charge, and as a result, it is able to be attracted to a positive or negative ion. Okay? Now, why does an ionic solid not dissolve? Is because none of that type of attraction exists. And so that's why if you try to dissolve salt in something like oil, which is a nonpolar solvent, there is no dissolving because there's no attraction. Now, what I want to do today is I want to talk a little bit more about the dissolving process and the difference between types of solutions. Now, when talking about solutions, there are generally two types of solutions that exist. What we have is one of them is called molecular solutions. Another name for this is covalent solutions. And what it is it's formed when a molecular compound, a non-metal, dissolves in a solvent. Now, another name for molecular compounds, in this case, if I were to do this here, this would be like covalent compound. Now, an example of a covalent compound would be something like sugar. So you have C6H12O6. So this is sugar. Now, normally it would exist as a solid, but when it dissolves in water, it becomes C6H12O6, and we have AQ. Now, this would be what we would call sugar water. This is the stuff that they use to, in your bubble tea, or when you dissolve sugar into your coffee or tea or whatever. Now, recall you have the phase symbol. This would be like a solid. And here, AQ means that it is dissolved in water. Now, why is sugar able to be dissolved in water? Because sugar is a polar molecule. It is somewhat attracted to the water molecules because water is also polar, and it's able to be broken apart. Let me show you what it looks like for sugar to be dissolved in water. So we have that here. Let's start it up. So in this particular case, what happens is you have sugar that's dissolved in water. What happens is water is a polar molecule. What happens is that it is able to attract the positive or negative ends of water. And again, it is pulled apart. Now, in this particular case, notice in the simulation, the carbon, the hydrogen, and the oxygen stay together. But because it is now surrounded by water and floating freely in the water, this is why we have the change in phase from solid to AQ. Okay. Now, let me get back here. These solutions do not conduct electricity because there are no ions present to conduct electricity. Now, for ionic solids, it's formed when ionic compounds, or ionic solutions is formed when ionic compounds, a metal, non-metal, are dissolved in water and break down into their individual ions. Now, for this, let's say we have table salt. So we have NaCl solid. This would be like your table salt. Now, when we dissolve it in water, what happens is the breakdown is a little bit different. It actually breaks down into their component ions. So you have sodium and chlorine -1. Notice the phase symbol of AQ. Okay? Notice those phase symbols there. Now, what you have is you break them down into their individual ions. Now, sodium is a +1 charge, chlorine is a -1 charge. This you remember from the periodic table. And what's happening is that they are existing in solution as ions. Now, one thing that you should be aware of is this. Notice it's a 1-to-1 ratio. 1 sodium chloride breaks down into 1 sodium and 1 chlorine because of the fact you want to balance the equation. Now, this process of dissolving is called dissociation. The breaking apart into its component ions is called dissociation and is represented by a dissociation equation. Okay? Now, one thing I would like you to be aware of is this. This looks very similar to something you learned back in chemical reactions. You might say, let's say here, Mr. Chan, could it be decomposition since we have 1 sodium breaking down into its component parts? Could we say that this is decomposition? And the answer is no. Okay, so one thing you should be aware of, whether you write it or something like that, wherever, you should notice that dissociation is not the same as decomposition. Now, dissociation would be something like NaCl breaking apart to Na plus and Cl minus 1. Okay, and this is in solution. Decomposition would be breaking apart into its neutral elements, Na and Cl2. Okay, so here would be AQ, this would be AQ, this would be solid, this would be gas. So they look similar, but please make sure you understand the difference between dissociation and decomposition. One, you break apart into ions in solution. That would be dissociation. Decomposition, you break apart into its component neutral elements. Okay. Now, the dissociation equation gives us the mole ratio of ions or concentration of ions in solution. So let's say, for example, I want you to find the concentration of calcium plus 2 and concentration of hydroxide in a 0.1 molar calcium hydroxide solution. Now, the first thing is you need to recognize is this is an ionic solution. Calcium is a metal, hydroxide is a non-metal, so it breaks apart into calcium and hydroxide. So here we have calcium hydroxide breaking apart to calcium plus 2 aqueous and 2 OH minus 1 aqueous. Okay. Again, where do we get the charges from? You get it from the periodic table or your table of polyatomic ions. And why is there a 2 in front of the hydroxide? Is because you want it to be balanced. So in this case, if you have 0.100, the calcium would be, this is molarity, this would be 0.100 molarity, and this one would be 0.200 molarity. The reason being is because it's following the mole ratio of 1 to 1 to 2. You could think of it like this. Calcium hydroxide would be like a complete bicycle. If you break down the bicycle into its frames and wheels, that is like breaking it down into its component ions. So if I had 10 bikes, I would have, breaking it apart, I would have 10 frames because one bicycle has 1 frame, but 20 wheels because one bicycle has 2 wheels. That is the same idea. Okay. Now, one thing about solutions, when talking about solutions, we use the term molarity to express how many moles of substance was dissolved in a liter of solution. Now, hopefully you remember this from moles, where you had to use this little triangle where you had moles is equal to molarity divided by liters. Now, let me give you one example of this question. So let's say, for example, if you look at your concentration and dilution calculations, let's say we had the example here. Let me see here. Where's my worksheet? Oh, there we go. So let's say, for example, let's have question number 4B. Calculate the weight of NaOH in 1 liter of a 1.5 molarity solution. Okay, so in this case, if we were to take a look at worksheet number 4B, first step is find moles of NaOH. So what we have is we will take 1.0 liters times 1.5 molarity. And that gives me an answer of 1.50 moles of NaOH. Number 2 is we find the weight. When we find the weight, that means we're looking for grams. So we have 1.50 moles times the molar mass of sodium hydroxide, which is 23 plus 16 plus 1, which is 40.0 grams, all over 1 mole. And then I get an answer of 60.0 grams of NaOH. Okay, now I'm going through this a little bit quickly because this should be reviewed from things back in the moles. And if you don't believe me, go back to your mole concept and remember we did molarity, which was a very similar type of question. I actually did the same one. All right, folks, that is it for today. Thank you very much. I will be assigning some homework in class, so do make sure to complete the homework. All right, folks, thank you very much. Have a good day. Bye-bye.